Now continuing our discussion on HCF and LCM of two numbers, right? You would recall that the product of two numbers is equal to their HCF and their LCM. Now we'll expand on this idea a little bit. Now we'll expand on this idea a little bit by taking an example, and the example is of these two numbers 18 and 30, and let's prime factorize them and find out their HCFs and LCM. So 18 is 9 to the, so 2 times 3 squared is 18, and 30 is 2 into 3 into 5. Now their HCF is, so 2 and 3 are common factors, so I'll just write 2 and 3 here. Sorry. And for LCM, I'll write all of them. I'll write 2 and 3 and 5, right? So I'll give the lowest powers to the HCF. Lowest powers of 2 are 1, lowest powers of 3 is 1 again. Highest powers I'll give to the LCM. Highest power is 1, highest power here is 2 and 1, right? So the HCF is 6 and the LCM is 90, right? Now it's actually interesting to see that the HCF is a part of both 18 and 30, and it is the highest possible number, which, you know, it's the highest factor of both 18 and 30, highest common factor of both 18 and 30, right? This means that 18 can be written as the HCF into something, and that something here, the only thing which is left behind is a 3. Likewise, the other number 30 can also be written as the HCF and whatever is left behind. So a 5 is left behind here, right? So this is how I can write both 18 and 30. So 18 is HCF into something and 30 is also their HCF into something. Now, it's interesting to note that these two numbers will have nothing in common, or in other words, these two numbers are going to be co-primes. So 3 and 5 are the numbers which are uncommon, let me say, right? Because 3 is missing, the extra 3 is missing in 90, in 30, and the extra 5 is missing in 18, right? So 3 and 5 are uncommon factors, right? So let me just write 3 as the uncommon factor in 18, and 5 is the uncommon factor in 30. So I can write my first number 18 as HCF into the uncommon factors in 18, and I can write 30 as the HCF again into uncommon factors in 30, and both of these are going to be co-primes. Now why do you think these are going to be co-primes? These are going to be co-primes because if, let's say, there was something in common between these two numbers, then these would clearly form a part of the HCF, isn't it? So if, let's say, there was a 3 into 5 which was left here, then the 5 from here and here would by definition have to form a part of the HCF. Therefore, by definition, what is left outside of HCF in here is not going to be present in here, and likewise, by definition, whatever is left outside of HCF in the number 30 is not going to be present here, right? So let's put these numbers in here, right? And why don't we do a general result? So 18 into 30 was equal to their HCF multiplied by their LCM, right? However, 18 can be written as their HCF multiplied by the uncommon factors in 18. Similarly, 30 can be written as their HCF multiplied by the uncommon factors in 30, and this is equal to the right hand side, HCF into LCM, right? So now what I can do is I can cancel out one HCF, and I notice that, now just let me swap the right hand side and bring it over to the left hand side, and the left hand side goes to the right side. So LCM, this is what I'm left here on the right hand side, equals HCF of these two numbers multiplied by the uncommon factors in the first multiplied by the uncommon factors in the second, right? So that means if I, let me use another pen. So that means if I were to express 18 and 13 in this form, HCF into the uncommon factors in the first one and 30 as HCF into the uncommon factors in the second one, then these three, their product is equal to the LCM, right? Of course, what this also tells me is that LCM has HCF also as one of the factors, right? So if I generalize this for two numbers A and B, now let me use this one. So LCM of two numbers is going to be their HCF multiplied by the uncommon factors in A. That means all the factors which the HCF left out in A, and uncommon factors in B, which means all the factors which HCF left out in B, right? So this gives me my, this further gives me my result.